Hey everyone, and welcome to another video. Today we are diving into the world of web application security and taking a comprehensive ethical overview of a powerful tool available on Kali Linux known as SSTIMap. Before we get started, I want to make it absolutely clear that this video is strictly for educational purposes. We are focusing purely on the theoretical overview and the architectural capabilities of this tool to help security professionals, ethical hackers, and web developers deeply understand the risks associated with modern web vulnerabilities. We will not be showcasing any practical exploitation or targeting any live systems today, as our ultimate goal is defense, mitigation, and securing digital infrastructure. To truly understand the value of SSTImap, we first need to talk about the specific vulnerability it is designed to hunt down. That vulnerability is server-side template injection, commonly referred to in the cybersecurity community as SSTI. In modern web development, template engines are widely used to separate web presentation from business logic. They allow developers to create dynamic HTML pages by embedding server-side variables within a static web template. However, when user input is unsafely embedded directly into a template rather than being passed in safely as data, attackers can inject malicious template directives. This allows them to manipulate the template engine itself, which can lead to catastrophic consequences. SSTImap is a highly specialized penetration testing software specifically built to identify these exact scenarios. It acts as an automated scanner and exploitation framework that can thoroughly check websites for both code injection and server-side template injection vulnerabilities. What makes SSTI so dangerous is that it goes far beyond simple front-end vulnerabilities like cross-site scripting. When an attacker successfully exploits an SSTI vulnerability, they're essentially executing arbitrary code on the back-end server. SSTImap is designed to ethically demonstrate this exact risk by showing how these vulnerabilities can be leveraged to exploit the system, eventually giving access to the underlying operating system itself. This tool was meticulously developed to serve as an interactive penetration testing companion for SSTI detection and exploitation. It is not just about detecting a surface-level flaw and stopping there. It is built to allow for much more advanced exploitation workflows. Security professionals use it to interactively probe the environment, map out the underlying technologies, and confirm the true severity of a finding. The tool draws its immense power from a rich database of payloads and techniques. These are carefully crafted injections based on extensive industry research. For instance, many of the core concepts and payloads stem from James Kettle's highly influential security research paper, Server-Side Template Injection: Remote Code Execution for the Modern Web App. Furthermore, the tool incorporates sophisticated techniques from various other public researches, significant contributions made to its predecessor project known as TPLMap, as well as extensive independent research conducted by the developer. It is also worth noting that more payloads for SSTImap can be found dynamically as the open source community continues to contribute to the project. When testing modern, complex web applications, security testers rarely encounter simple, straightforward vulnerabilities. Web applications often employ heavy sandboxing, input filtering, and context-specific encoding that make exploitation incredibly difficult. This is where SSTImap truly shines. It is highly capable of exploiting intricate code context escapes. This means that even if a developer has tried to sanitize input or restrict the execution environment, SSTImap has built-in mechanisms to systematically attempt to break out of those constraints. Additionally, the tool handles blind injection scenarios incredibly well. In a blind SSTI vulnerability, the target application is indeed vulnerable, but it does not return the output of the injected payload directly in the HTTP response. Testing for this manually can be incredibly tedious, but SSTImap automates the process of confirming these silent, blind executions. Beyond standard template injection, the tool also boasts robust support for evaluating code injections. It can expertly handle eval-like code injections across a massive variety of programming environments, specifically supporting Java, JavaScript, PHP, Python, Ruby, and generic unsandboxed template engines. For those of you who have been in the cybersecurity field for a while, you might be thinking this sounds remarkably similar to another classic tool called TPL-Map. You would be correct. SSTImap is actually based heavily on TPL-Map's original code. However, it is crucial to understand that SSTImap represents a massive modernization of that framework. A key difference to remember is that even though this software is based on TPL-Map's code, backwards compatibility is not provided. This intentional break from the past allowed the developers to heavily modernize the architecture and introduce a host of new powerful features that address the realities of contemporary web application security. Let us break down the key differences and improvements that make SSTImap a modern necessity for any ethical hacker. First and foremost, the tool added two entirely new techniques dedicated to both the detection and exploitation of SSTIM, significantly broadening its testing scope. One of the most praised additions by the security community is the interactive mode, which can be triggered using the -I flag. This interactive mode completely transforms the testing workflow, allowing for easier step-by-step exploitation and detection compared to simply firing off noisy automated requests. Another incredibly smart feature is the use of simple eval payloads as response markers. In cases where payload reflection is present on the web page, SSTImap uses these markers to efficiently confirm that execution actually took place, reducing false positives and saving valuable testing time. The developers also recognize the need for generic testing capabilities. They added brand new payloads specifically designed for generic templates. If you're auditing a proprietary web application and want to test all context thoroughly, you can simply use the -- generic argument. Complementing this is the eval generic module, which provides robust generic eval template injection detection. When it comes to proving the impact of a vulnerability during an ethical engagement, execution is key. SSTImap facilitates this perfectly with its base language eval-like shell accessible via the -X flag. Alternatively, it allows for the execution of a single command using the -X flag. The overall payload database has been heavily updated. Not only were new payloads added to support a wider array of modern template engines, but many of the existing older payloads were refined and updated to bypass newer defensive mechanisms. To ensure the tool can continue to grow organically, the architecture was overhauled to feature a modular plugin structure. This allows users to easily handle additional plugin installation to extend functionality. Furthermore, the tool now includes vital support for different post data types. Modern web applications utilize diverse data structures, and SSTImap can handle them natively. To make the initial discovery phase smoother, the tool also benefits from newly added crawling and form detection capabilities. It can navigate an application, find input vectors, and queue them for testing. For the user experience, short versions have been added to many command line arguments to speed up the testing process. However, be aware that some of the old command line arguments from the TPL-Map days were changed, so checking the -H help menu is highly recommended. Under the hood, the code is changed to use newer Python features, ensuring better performance and maintainability. It is important to note that due to this upgrade, the Burp Suite extension was temporarily removed simply because Python does not currently support Python 3. Finally, while we have discussed the interactive and advanced features heavily, it's worth noting that SSTImap in determined mode is very similar to TPL-Map. It is fully capable of automatically detecting and exploiting SSTIM in multiple different templates. After the exploitation phase is successful, SSTImap proves its worth by providing the ethical hacker access to direct code evaluation, full OS command execution, and D-file system manipulations. Understanding tools like SSTImap is absolutely essential for defending modern infrastructure. By knowing exactly how attackers operate, we can build stronger, more resilient web applications. Thank you so much for tuning in to this overview. Stay safe, code security, and I'll see you in the next one.